Tell me your name and what your work is, what your work entitles.
My name is Marco Kaltofen. I'm a civil engineer. I'm with Worcester Polytechnic Institute, where I do research on airborne radiation spread.
Can you give some more detail on what encompasses airborne radiation spread?
I think a lot of people are hearing a lot about radiation from the Fukushima plants in Japan, and it's really hard for folks to understand. And what my research area is about is trying to pick apart exactly how that radiation spreads, how it spreads at the plant site, how it moves through the region, and how eventually it starts to travel intercontinentally. So examining what it is in the environment that's carrying this radiation so that people very far away can be exposed to it. And the other part of that is when we do find radiation in the environment, trying to track back to where it came from and what the source is, and maybe there's something that could get done about it.
So how do you go about tracking specifically where a source of radiation or a toxin comes from?
Well, one of the biggest things about the radiation from Fukushima or any kind of nuclear accident like that is that most of the radiation is bound to particles, little specks of dust. And if you know how big those particles are and what they're made out of, you can predict how far they're going to travel, how many you're going to breathe in, and what kind of risk people face depending on where they live because of an accident like that.
Okay. So how do you go about tracking specific particles?
Well, one of the first things that we did when the accident began back on March 11th was to start taking air filter samples. And some of what we do looks a lot like a home air filter that a lot of people might have that removes dust from the air. We just blow air through a filter. We know how long we're doing that. We know how much air goes through the filter, and we just capture all the dust particles that are left. You can actually just weigh them and find out how many you have. And then we examine those particles that we capture one by one and look to see what kind of radioactivity they carry and how much radioactivity. It gives us an idea of how much radioactivity people are actually breathing in, because we all have a filter that we carry around. It's called our lungs. It takes particles out of the air. So what we're doing is mimicking what happens in the human body. And then we just use the instruments at the university and we examine any radiation coming off those particles.
All right, so sticking with the example of your work in Fukushima, so you're taking air samples directly from there, from that region?
We're doing several different things at the same time from Japan. We have a large crew of people who have volunteered and collected samples. Many of them have technical training. They're part of an organization called SafeCast. It's essentially crowdsourcing environmental sampling, where we have people who are living in the area, who have technical knowledge, who are using the same type of radiation detection and sample collection equipment that you might use in any kind of university here in the United States. The samples are collected, they get sent overseas, and we look for those specific radioisotopes, things like cesium or uranium, that are in those different particles, and try and measure exactly how much might be in the air, how much is in the soil, how much is in the dust, and get a feel for what's happening as you get further and further away from the Fukushima plant.
Okay, so you're measuring the overall percentage of radioactive particles?
One thing that I have to admit that's kind of gotten my goat about the whole way we have reported on what's happening in Japan is we hear all these different analogies. We're trying to describe radiation as, well, this is the same as background radiation, or this is the same as taking an airplane from New York to San Francisco, or eating a banana. Bananas have a naturally radioactive element in there in tiny proportions. None of that really makes sense. What we're really worried about is there a dust particle that is small enough that you can inhale it, get it in your lungs? It's radioactive. It's going to sit there and potentially cause a tumor in your lung cells. The same way smoking cigarettes could cause a tumor in your lung cells. That's what we're worried about. We want to see if that radiation is spreading in a way that might actually harm folks. The way we do that is we look at what's actually in people's dust, whether it's from their home or dust that might settle on, say, on a sidewalk, or from an air filter. Or probably the biggest set of air filters we have are the air filters from automobiles. They're sucking in tremendous amounts of air, they're driving all over, they're exposed to a lot of dust. So after a couple of months of use, we have folks in Japan sending us the air filters from their cars We spread them all out, and you actually can lay those air filters on top of a piece of film. And unfortunately, because radiation exposes film, whenever we do that with a filter from certain parts of Japan, the film turns black. There's enough radiation in the filters from cars or even from a home. It will blacken X-ray film. And to a lesser extent, that will happen in cities even very far away, like Tokyo, over 100 miles from the accident site. And frankly, if you look at some samples that were collected in the United States, you'll even find 1 or 2 particles on your filter that will blacken film. And that means that there must be more of them out there that we're not capturing.
So how do you know that the particles that you are collecting, let's say in Japan, are specifically from the Fukushima disaster as compared to, let's say, some residual particles from either above ground testing or the Hiroshima and Nagasaki bombs?
There are other sources of radiation in our planet. There were other atomic bomb tests. There have been other accidents like Chernobyl, and they've all left particles that can float around, and you could test them and maybe mistake them for something from Fukushima. But Fukushima has something very unique because it's so recent. There are certain isotopes that don't last very long. They only last for months or a few years. And these isotopes from things like Chernobyl 25 years ago, or nuclear testing almost 50 years ago when nuclear testing peaked, those isotopes have decayed away. You don't find them anymore. So if you find some of these shorter-lived isotopes, like, well, in the beginning we found radioactive iodine, and we still find cesium-134. It's an isotope that lasts, about half of it decays every couple of years. So if we still find a lot of cesium-134, that means that we are still seeing something that was recent. So there haven't been any other nuclear explosions other than Fukushima in the past few years. That's a tag. That's a fingerprint. You find the cesium-134, it means that you're probably looking at something from Fukushima and not something from Chernobyl.
And is cesium-134 then what you use as the signature, or is it a combination of that and other elements that you can use as a signature, again, specifically to Fukushima?
Well, probably the biggest thing that we recognize is cesium-134. You'll find another form of cesium called 137 that tends to last a few decades, about 30 years before it decays by half. So when you see those two together, that's telling you that we're much more likely to be seeing something from Fukushima. And in the early weeks of the spill, when we saw iodine-131 that has a half-life of about 8 days, that was pretty definite. We got plenty of samples back in March and April that had a lot of iodine-131. If I pull out the same sample now from the storeroom, that iodine-131 is gone. That's all decayed away. But we'll still find that 134, and a few others too. Things like ruthenium-103 that have a half-life that's a little over a month. So that's something that will last a little bit longer.
Arnie Gunderson with Fairwinds Associates, is that?
Yep.
Reported a couple months back, I believe, about hot particles showing up on the west coast of the United States. Have you run across any evidence of similar to that?
We certainly do see hot particles on the west coast. It's not like being in Japan. You know, if you're in Tokyo, you're getting a pretty significant dose, even though it's outside the evacuation zone. But the winds generally blow from west to east, and we're east of Fukushima. So without any doubt, you would find those particles. And if you take a big enough air sample, you'll find them. Back in April, we probably found a lot more. We were really beginning to detect that first real pulse of hot particles that came from Fukushima and blew towards the east. So they were fairly easy to detect. EPA detected them from not just on the west coast, but from Hawaii all the way through the U.S. and to the east coast as well. We saw the pulse from Fukushima in Boston. So there isn't too much doubt of that. We also have occasionally seen what's called a rainout. A rainout is when you might have radioactive particles passing by in the atmosphere, and a rainstorm will wash them out over a specific place. So if you go to a certain spot, and we've seen this happen in Oregon, we've seen this happen in Washington, you might find a small locality that got a lot more radiation than everyone else. And it's just chance. It's just bad luck. I think the existence of hot particles in Seattle and the West Coast it was predictable, it's well documented, And it's probably going to be impossible to find all the places where those hot particles ended up. There are just too many isolated spots.
Do you believe the hot particles that went beyond Japan are a threat to the population where they are being found?
Well, a hot particle in Japan or a hot particle in the United States, it's going to do the same amount of damage if it has the same amount of radiation. The only thing that's different is the odds. If you're in Japan, you're much more likely to be exposed to it. In the US, it's probably more of a rare event. You're a lot less likely. But it may be that we'll never really know in the US which people suffered health damage that was related to Fukushima. We don't really have a way of tracking where an individual person's cancer came from if it's because of a random event like that. If someone was in Fukushima at the time, you might say, all right, well, you got a cancer, you were in Fukushima, we know where it came from. Or if you have radioactive dust in your home, you can go and test it, you can see and say, well, this was probably the cause. But, we got the hot particles here. They were at relatively high concentration compared to normal for a matter of weeks or maybe as long as a month, depending on where you were. And we just don't know. We know we increased the risk, but we can't point to anybody and say, you better get checked.
Are there places that citizens who are concerned that they might have hot particles or dust from an event like the Fukushima disaster, that they can have their homes or workplaces sampled and tested?
Well, if you were in Japan and you were close to the site, it's highly recommended. In a lot of prefectures, they actually are going house to house. And while the quality of the testing isn't perfect, it seems fairly wise. Once you get to the US, you're talking about using some fairly expensive equipment to get it done. You could get it tested, but I'm not sure it would be meaningful. What's happening here is they're hot particles, but they're far enough and few enough in between that it's probably not going to be possible to go back and find out what your exposure was. I mean, they came here, this radiation. It was a little hard to predict exactly where it was. I don't think we've got the testing horsepower to figure out who those individuals were who might have gotten an exposure. I know some folks ask me, well, I look at the map and I see that we're directly to the east of Fukushima. Should I move to Chile? So that might be an overreaction. I wouldn't tell anybody to move off the West Coast. I think it's more a matter of something happened that we didn't want to happen. We know it's going to impact public health. There's not a whole lot you can do about it once you let the horse out of the barn. Hell, the horse took the barn door with it. I mean, we're just stuck. This was an accident that needed to be prevented. It's hard to respond to it.
Sticking with just the situation here in the U.S. from Fukushima, there were many people on the West Coast that were concerned immediately after the accident whether it was safe to be outside in the rain and or eating things from their garden. Do you feel that was justified?
Well, that was the reality after Chernobyl. There were people who might not have been as close as some others to the site of the accident, and they got unlucky. There was a rainout. They had high levels. It happened after bomb testing. It's one of the reasons we stopped. The bigger public health concern at this point, since the largest wave of hot particles has already gone by, and assuming nothing else bad happens, and that's a big assumption because things are not stable in Japan yet, I would think the most likely way you would be exposed to Fukushima radiation in the United States might be through the food chain. Because we know a lot more radioactive material went into the ocean and is going to be part of the human food chain through fish products and ocean plant products like seaweed. So I would think that's an area where we should be doing more testing right now, because I think that's where we get the most bang for our buck in preventive care.
Is that something that can be a standard test on fish catches?
Oh, it's a lot easier to do testing of food products that are making their way into the commercial distribution system than it would be to look for these rainouts, which are, like I said, they can often just be bad luck. We're not able to predict where that's going to happen. The testing of food is a lot easier. Unfortunately, it's my understanding the FDA has chosen not to test food, and the Japanese food testing program has turned out to be leaky, letting a lot of things go to market that probably shouldn't have. I mean, there's certainly plenty of testing where people have gone to a school in a city and found that a batch of milk was too hot to be used. But that's just one school. What about the schools that weren't tested? So there's a lot of that happening. And so, you know, undoubtedly things are getting into the distribution system from Japan that are a problem. If we were to look at food products in the United States, I would think fisheries is a place we might want to look first, and then we do a lot of testing for all kinds of things in soils as part of agricultural extension services. This is not hard to do. I'll bet that most West Coast farms are going to turn out to be negative, but again, because of rainouts, there'll probably be a few that, that do have high results. I know that we've tested at least 1 or 2 soils from the West Coast that had traces of cesium-134 and 137. I know that the Berkeley laboratory down in California had the same result with a slightly larger sample set, where they were finding cesium and early on finding iodine in food products. So that's a given. There's no reason not to do the testing.
What's your opinion of here in the U.S. of the overall robustness of our testing program?
Well, if we're not testing food, then we're like the BP oil spill. We're just doing a lousy job. You know, we're looking the other way. So that's not good enough. I mean, this testing technology is easy. Just because you want to do testing, it doesn't make you anti-nuclear. You just want to know what's in the food. I mean, that's pretty straightforward. I'm surprised that we're not doing it.
If you were in charge of the testing program for the U.S., where would you be implementing the testing from? Would it be federal program? Would it be statewide program? Local?
We have some localities that do testing. Most of the food testing that was done early on, back in April, May of 2011, was done by the federal government. It's a testing program that we probably should be doing regularly anyway. I mean, we have 60 different testing laboratories whose sole job around the world is to test for illicit nuclear detonations. Now, how often do those actually happen? Not very often. It's part of the Comprehensive Nuclear Test Ban Treaty. Costs a lot of money to have those labs run, and they haven't found anything. Why not spend some money and do testing of food that people are actually eating? And we know there's problems with the distribution system, that some of this stuff is getting into the stores and supermarkets and people are buying it.
Getting back to the situation directly in Japan, we're seeing articles, newspaper articles coming out now about how I just believe it was in the last couple days, where the amount of fallout that the government there estimated was they were off by a factor of 10. There's been other information that the cesium has been found at 250 kilometers away from the Fukushima site. Can you speak to any of that?
A couple of things have gone wrong with the testing program that have hurt us in terms of understanding the accident. Number one is that a lot of sensor systems were knocked out by the tsunami, so that most of them were not operative. And because of the degree of damage is at a scale so much greater than what anyone expected for these reactors, we've lost the ability to understand what's going on inside these buildings. When we have a temperature sensor, it was put where the designers thought the fuel was going to be. That fuel is either exploded, lost, melted, moved. It's not where it's supposed to be anymore. It's moved out of range of those sensors. So we just don't know the numbers. If you don't have that kind of basic information, it's easy to make big mistakes about the size of the release. And then what you're reduced to is going out in the environment and looking how the radiation is spreading, and then trying to calculate backwards and figure out how much material you lost. There's a lot of error in that. And unfortunately, sometimes it's just hard to change your frame of reference, to understand, you know, things are different. We had an accident that was much bigger than we thought we'd actually had. We would have a much smaller figure if we had just stuck to what the design said might happen. Well, in reality, the accident turned out to be worse than whatever the designs told us was going to happen. We're out of our depth. You know, the models don't cover, you know, losing 3 reactors in a spent fuel pool at the same time in complete meltdowns. So it's new ground for us, and there are mistakes. And that means knowing how many errors you could make and how many sensors we lost and how far we are from our design scenario, you need to do a lot more testing, a lot more than you might have expected. And unfortunately, you know, we haven't caught up with that yet. We're not doing the amount of testing we really need to do.
And if you were in charge, how much testing would you be doing?
If I were in charge of Fukushima, and I'm not, and sometimes I wonder if anybody is, but if I were in charge of the testing, I would do enough work so I could tell people, all right, this is how much we lost, this is where it went, and this is what we can expect to happen in the future. We're nowhere near that. You have to do enough testing where you can actually describe what happened, who was affected, and so on. You wouldn't have to depend on a nuclear engineer, even somebody as good as Arnie Gunderson, to try and guess from a distance who was exposed and how much. You'd have the number. We haven't got the number.
So what's your thoughts on why the Japanese government or TEPCO or the research university community there isn't following through and doing the amount of testing that they should be?
You know, one thing I have noticed is the research community in Japan really is stepping up. There are a lot of scientists who are out there collecting this data. There's SafeCast, a lot of people who care very deeply about Japan, who are going out, and sometimes I think at some personal risk, going out and collecting these samples and getting this data and publishing it, letting people know what's happening. So I don't have any fault with the Japanese research community. I think TEPCO is out of its depth. I don't think they ever expected to be responding to something like this, even though they took 6 nuclear power plants and put them in a tsunami danger zone. I don't think anyone ever thought that this day would come, and it did. And as far as the Japanese government is concerned, they're looking at their 5th prime minister in 6 years. So we're lacking the kind of continuity that I think we need to address a problem like this.
You just recently returned from the Hanford Nuclear Reservation?
Yeah, I just got back from the Hanford Nuclear Reservation where we're doing testing.
And can you tell us about the tests that you've been doing there and the motivation behind that?
One of the things that we found at Hanford, which, by the way, is probably the most contaminated site in North America as far as radiation is concerned. It is a problem that's been going on for decades, and frankly, we're going to be dealing with the Hanford cleanup for literally thousands of years into the future. We have so much contamination there, and a couple of different things are happening. One, the place is a sieve, and radiation is getting into the environment. And the second thing is that the people who are doing the most work to do something about it, the people that actually work at Hanford, are finding themselves the victims of contamination. And sometimes that contamination is something that they can even take home with them, where if they're exposed to radioactive dust on the job, like workers in many industries, that dust comes home on their clothes with them. So for us at Hanford Challenge, where I'm a board member, what we've been doing is trying to document some of the things that go on in the environment, and also work with whistleblowers, people who've been at Hanford, who've seen some of the safety issues, and who are trying to tell the public what's happening there. Working with them on policy matters that might improve their safety, but doing testing too. I mean, the American Chemical Society, not a particularly radical group, their motto has been, test us, don't trust us. Well, why shouldn't that apply to the Department of Energy? We want to do the testing. Because of the association I have with Worcester Polytechnic Institute and the instruments that they have donated to this research effort, and also the people that have helped support Hanford Challenge. We can get out there and do that testing and take our equipment and see how much people might be bringing home and exposing people and their families to, and how much is actually in the environment where people live, or where some of the First Nation people are consuming fish from the Columbia River and some of the impact that has on them.
Have you been doing this for a while now?
I know that Hanford Challenge has been doing this work for a good deal longer than I have. I started working with them when their organization had a different name back in 2003. And an attorney by the name of Tom Carpenter said, "Hey, you want a free tour of the most toxic site in America?" And like a dummy, I said, "Sure, let's go." And got a look at the place and said, there's so many low-hanging apples here. There's so many things that could be done to improve our understanding of what's happening and what's getting out of Hanford. Let's just do them. Let's not wait.
Have you found the DOE and the community there to be fairly supportive of your efforts?
I find the community to be pretty well educated about what's happening. They've lived with Hanford for a while. They're closer than a lot of folks. And they probably either work there themselves or know somebody who works there. So if I go to Tri-Cities, Hanford is a huge part of what makes those towns what they are today. So they do have a good understanding. I think everybody wants to know more about what's happening. And as far as Hanford Challenge is concerned, I think for the folks who are at Tri-Cities, it's nice to have a group that actually wants to see the place continue, get cleaned up, and work with the community, instead of just being some anti-group.
All right. What final thought would you like to leave with listeners, viewers, about the situation like we face at Hanford and/or the Fukushima disaster?
You know, I get this asked of me all the time. When I am testing here on the West Coast, sure, I can find some stuff from Fukushima. And when you're testing around Hanford, sure, you can find it. But, you know, the real question is, well, what does that tell you about what you should be doing different? And I think that's really important. I think we need to really re-examine what we're doing internationally and figure out if nuclear power really is safe and reliable the way we've done it so far. And I think we need to look at Hanford and say, are we getting the cleanup in a timely way without sacrificing worker health? You know, those are just some kind of big questions about how these programs, whether it's civilian nuclear power or Hanford and the cleanup, you know, that we need to keep asking ourselves and remember why we're doing it. It gives us an idea of how much radioactivity people are actually breathing in, because, you know, we all have a filter that we carry around. It's called our lungs. It takes particles out of the air. So what we're doing is mimicking what happens in the human body. And then we just use the instruments at the university and we examine any radiation coming off those particles.
All right, so sticking with the example of your work in Fukushima, so you're taking air samples directly from there, from that region?
We're doing several different things at the same time from Japan. We have a large crew of people who have volunteered and collected samples. Many of them have technical training. They're part of an organization called SafeCast. It's essentially crowdsourcing environmental sampling.
Tell me your name and what your work is, what your work entitles.
My name is Marco Kaltofen. I'm a civil engineer. I'm with Worcester Polytechnic Institute, where I do research on airborne radiation spread.
Can you give some more detail on what encompasses airborne radiation spread?
I think a lot of people are hearing a lot about radiation from the Fukushima plants in Japan, and it's really hard for folks to understand. And what my research area is about is trying to pick apart exactly how that radiation spreads, how it spreads at the plant site, how it moves through the region, and how eventually it starts to travel intercontinentally where they live because of an accident like that.
Okay. So how do you go about tracking specific particles?
Well, one of the first things that we did when the accident began back on March 11th was to start taking air filter samples. And some of what we do looks a lot like a home air filter that a lot of people might have that removes dust from the air. We just blow air through a filter. We know how long we're doing that. We know how much air goes through the filter. And we just capture all the dust particles that are left. You can actually just weigh them and find out how many you have. And then we examine those particles that we capture one by one and look to see what kind of radioactivity they carry and how much radioactivity. So examining what it is in the environment that's carrying this radiation so that people very far away can be exposed to it. And the other part of that is when we do find radiation in the environment, trying to track back to where it came from and what the source is, and maybe there's something that could get done about it.
So how do you go about tracking specifically where a source of radiation or a toxin comes from?
Well, one of the biggest things about the radiation from Fukushima or any kind of nuclear accident like that is that most of the radiation is bound to particles, little specks of dust. And if you know how big those particles are and what they're made out of, you can predict how far they're going to travel, how many you're going to breathe in, and what kind of risk people face, depending on where we have people who are living in the area, who have technical knowledge, who are using The same type of radiation detection and sample collection equipment that you might use in any kind of university here in the United States. The samples are collected, they get sent overseas, and we look for those specific radioisotopes, things like cesium or uranium, that are in those different particles, and try and measure exactly how much might be in the air, how much is in the soil, how much is in the dust, and get a feel for what's happening as you get further and further away from the Fukushima plant.
Okay, so you're measuring the overall percentage of radioactive particles?
One thing that I have to admit that's kind of gotten my goat about the whole